is just meant to be a key for the first worksheet on graphing quadratic functions, or what are known as parabolas. You can call them quadratics or parabolas, remember? So I thought I would look at several of the problems in your worksheet, and then you can work through and make sure you have the right answers or figure out what you're doing wrong at your own pace. That way, if we go too fast or too slow in class, you don't have to worry about that. So then on the second worksheet and for the exam, you'll be hopefully a lot better. Okay, so the directions for all of these problems were, and they'll be the same pretty much on any quiz or test you face. It says factor it and find the zeros. That's all we've been doing, factoring. Find the vertex. So for that part, remember the vertex and axis of symmetry. We're going to be doing negative b over 2a. And then graph it with that information and finally do domain and range. I probably won't do domain and range on all of them, but I'll try to do it on most of them. And I may do this in 2 videos just so you can split it up and not do it all at once. Okay, so let's look at the first problem. So I think this was number 1 on the worksheet. So first, I guess we're going to factor it. So we're going to say this is a trinomial. So we're going to say factors of 3. Well, there's not too many factors of 3. It's got to be 3 and 1. So then we're going to go x and x. And let's see. And what are we going to do? Negative 3, positive 1? Yeah, that adds up to negative 2, multiplies to negative 3. Sweet. So it's factored, so then we set each factor equal to 0. I'll do it explicitly on the first one. So we solve by going minus 1, minus 1. So x is equal to negative 1. And if we did that on this one, we'd get x is equal to positive 3. Okay, so then we can start thinking about graphing the parabola. So I'm going to get a graph going over here. Oh, I should do a double line. Let's see, do I have a double line option? I don't know. Ah, well, those should both be double lines, but that's okay. So let's see. Okay, so we can plot those points. Negative 1 is a 0, and or an x-intercept, and 1, 2, 3 is an x-intercept. Okay, then we're supposed to find the vertex, so we're going to go x equals negative b. Oh, negative, negative, right? I got to watch that. 2 negatives on this one. Negative b over 2a, and a up here is 1. So I'm going to have positive 2 over positive 2 is 1. So it looks like the vertex line, the axis of symmetry, is at 1. So I'm going to draw that with a dashed line. Let me do that. Okay, so I'm going to do a dashed line at 1. There we go. And I'm also going to label it. Make sure you label your line. So x equals 1. There's the axis of symmetry. That's an equals. Okay, then we plug that in to get the y for the vertex. So we get y is 1 squared minus 2 times 1 minus 3. So that's 1 minus 5 is negative 4. So the vertex is at 1, negative 4. And excuse my sloppiness, it's hard to write with the mouse. So 1, negative 4. 1, 2, 3, 4. Right there. This guy's facing up, so I think we know everything we need to know. So it's going to be like that. And the domain is going to be everything, right? Negative infinity to infinity. I'm not going to write that out. All parabolas have that. The range, though, let's write it. It's going to go from this bottom value. Oh, that was negative 4, right? So negative 4. And then it keeps going up, up, up to infinity. And I think the negative 4 actually needs a bracket, doesn't it? Okay, there we go. There's number 1. So I think I'll do 3 in this video and then start another one. Please excuse my computer. It likes to heat up on these. Okay, here's another one. Let's get our graph ready to go just at the beginning on this one. Let's see. What kind of options do I have here? Let's try this one. It's okay. Okay, there's our graph when we're ready for it. Okay, this one, I don't think it's a trinomial. They share something though, right? They share, in fact, an x. So I'm going to actually plot a negative x though. You could plot a positive or negative. I just decided to plot a negative. So if I pull negative x out of this, there's another x left. If I pull negative out of positive, I get negative. Pull the x out, the 2 is left. Okay, so we get negative x equals 0. So you divide and you still have 0. There's 1, 0. We can plot it. Oops, a little bit sloppy. Right at the origin. The other one's going to be x minus 2 equals 0. So I'm going to get x equals 2. So 1, and there's my other 0, my other x-intercept. Okay, we know this guy's facing down, right, because a is negative, so it's got to be something like this. And I already pretty much, without even computing it, know the axis of symmetry is in the middle. You know what? I'm just going to draw that right now, because I'm smart, just like you guys are going to be. So I'm going to put that right there. We can confirm that really quick by doing negative b over 2a. So x equals negative b is 2 over 2a. A is negative 1. So that's negative 2 over negative 2. Hey, that's positive 1. Hey, it was at positive 1. Good. That's what we thought. Positive 1. Remember, make sure you label your axis of symmetry. Okay, then we're going to plug that in just like we did last time. So y equals negative, and then we're going to put 1 squared, and then plus 2 times 1. 1 squared is 1, so that's negative 1 plus 2. That's a positive 1. So our vertex is at 1, 1. Let's write it. 1, 1. That's our vertex. So 1, and then up 1. So it must be up here. And then we said it was going down or up, right? It should make sense that the only way it's going to come down here and cross, if it went up like this, it wouldn't even come down and cross these guys. So it has to come down and cross these guys like this, right? So there's that quadratic shape, that parabola shape. Okay, so we've pretty much done all the important stuff except domain and range. Domain, once again, for all parabolas is everything. You can keep going out this way. It looks like it gets steep, but it keeps going out. And it keeps going out. So the domain, I'll write at this time, is negative infinity to infinity. And the range is going to be, this time, negative infinity because it goes up from the bottom. And how high does it go? I think only up until 1, and it stops right at 1, so we get a bracket. Okay, one more example for this video. Oh, that's the same one. Let's delete that page. Okay, this guy. Once again, I'm going to start by drawing a nice graph over here. There we go. Okay, this guy, factoring wise. Oh, they don't share anything. There's not 3 terms. Oh yeah, these look like square guys. These are difference of squares. So I'm going to say, okay, this is difference of squares. So I'm going to say x, because that's what's being squared there, and what's being squared there is 5. Difference of squares has 1 plus and 1 minus. Okay, so I think we're going to get negative 5 as a 0 from this one, and positive 5 as a 0 from this one. Remember, the reason you do that is you go x plus 5 equals 0. You subtract the 5 on both sides, and you get negative 5. If you're having a little trouble here, let me make sure to show that I'm just doing this. Just solving really basic equations. So we get 1, 0 is at 5. 1, 2, 3, 4, 5. So there's 1. If we did it with that one, oh, this one's negative 5, isn't it? So this one actually is the one over here. 1, 2, 3, 4, 5. That one. This one, if we go x minus 5 equals 0, and we add 5 to both sides, then we're going to get positive 5. That's this 0 over here. Okay, is this guy facing up or down? I think it's facing up. So this parabola must look like this. The only question is, how far down does it go? We can already see, once again, the axis of symmetry has got to be right in the middle. Let's confirm that. So x equals negative, what's b? There is no b, there's no x. So negative 0 over 2 times 1. What's 0 over anything? I think it's just 0. And that's where we thought it was going to be, right? Right in the middle at 0. So let's draw that anyway, just to make sure we have it on there. So our axis of symmetry is going to be right here, and we'll label it at x equals 0. The only question is where is, we know this is facing up, so the vertex has got to be somewhere like here, maybe down lower, I don't know. So we're going to plug in 0 and see what we get. If we plug in 0, then we get y equals 0 squared minus 25. 0 squared is 0, so that's negative 25. So that vertex is pretty far down here. We'll just pretend this is negative 25. Put the vertex, and we can draw our parabola. Like so. Oh my gosh. That is not the best drawing. Let's try it one more time. There we go. Tried to hit the 0. It's supposed to hit it, right? Okay, there's our parabola. Domain and range. Once again, domain is going to be everything for parabolas. When you have quadratics, it's everything. For other functions, it's not always that way. So domain is going to be everything. Infinity to infinity. The range, what have we got here? This one starts at some value, negative 25, right? It's actually there, so bracket up to infinity. And let's just talk about, I think some of these questions ask you max or min. This is a minimum, right? So the minimum value is negative 25. So you can write that too if you need to. Should we do one more in this video? I think so. Let's do one last problem, and then I'll do another video if you want to take a break. Okay, get our graph going. Okay, this guy, factoring-wise, he's a little tougher. So you could do this little arrow thing and factor it that way, but first, remember, you should always try to see if they share anything. And they do. This time they share a 3, so let's pull that 3 out. So, and then see what happens. So if we pull the 3 out, we have x squared. 12 divided by 3 is 4, and there's an x left. 9 divided by 3 is 3. So that's what's left. Oh, and I think that factors, right? That's a factorable problem. So let's see. 3 and 1? Yeah, that adds up to 4. So x plus 3 and x plus 1. Definitely. So then we can set these two parts equal to 0. X plus 3 equals 0. Subtract the 3 and we get negative 3. Oh my gosh, that's not 3. So negative 3. And then x plus 1 equals 0. So you get negative 1. So negative 1 is one 0, and negative 3 is the other 0. This guy's facing up, so we know it's somewhere in here. So we already know, once again, the vertex has got to be somewhere on this line. Let's confirm it. Negative b over 2a. So we go negative b is 12 this time, right? A, b, c over 2a is 3 this time. So negative 12 over 6. That's negative 2. Oh, we knew it was going to happen at negative 2, though. So then we, oh, it doesn't look right. Let's get him maybe about right there. Ah, that's pretty good. Okay. So negative 2, label it. Remember, vertical lines are x. If you had a horizontal line, that would be y. Okay, let's plug it in. So y equals 3 negative 2 squared plus 12 times negative 2 plus 9. Negative 2 squared is 4. Negative 2 times 12 is negative 24. So we've got 12 minus 24 plus 9. So that's going to be negative 12 plus 9. So it's going to be negative number, isn't it? Negative what? Negative 3. Okay, so the vertex is down here at 1, 2, 3. About right there. Let's think, is this going up or down? Once again, A is positive, and it would have to go up in order to go through those anyway, so pretty obvious that it's going to go up. And something like that. And let's just do the range. Domain is everything again, right? Range is going to be from that bottom value of negative 3 up to infinity, bracket, parenthesis. And is this a max or a min? I think this is a min, so we could say the minimum value is that -3. Okay, so I hope that helps. I'm going to do some more examples in another video. Make sure you watch both during class. I'll see you next time. Okay, hi guys. This is going to be the second part of the worksheet video key. So this time we're going to do a couple more problems pretty much. So here's another quadratic. We're going to follow those same instructions as last time, if you remember. Factor it and find the zeros. Find the vertex and axis of symmetry using x equals -b over 2a. Then graph it and do domain and range. Okay? All right. So let's throw a graph up there real quick so that we're ready when we start assembling our pieces of information. Okay, this guy is 3 terms, right? I don't think they share anything. Oh, actually, yes, they do. They do share a 2. So let's factor that 2 out. It looks like my computer's already getting hot again. Crazy. Okay, so if we pull 2 out of the first one, x squared is left. Pull 2 out of this one, that means 9x is left. Pull 2 out of 72. What's 72 divided by 2? Oh, might need my calculator. Give me a second. Okay, that's 36. All right, then we look at this and say, hey, can we factor that any farther? I think so. Let's think about factors of 36. We have 6 times 6. No, that's not going to give us 9. What else? 4 goes in. 4 times 9. That's not going to give us 9. Dang it. What else am I missing? Does 12 go in? I think 12 goes in. 12 times 3. Oh, that might give us 9. Okay. So if we go x, 3, and 12, how would this work? We want a positive 9, so would that be a positive 12 then? Yeah. -3 times 12 is -36. -3 plus 12 is positive 9. Sweet, that's it. Okay, so this time I'm not going to set it to 0 explicitly, so this guy is 0. When you put x minus 3 equals 0, you're going to get x equals positive 3. This guy, when you put x plus 12 equals 0, you're going to get -12. So if this is like -5, -10, we're going to have a 0 way over here at -12, and then 1 if this is 5, 1 about right there at positive 3. Okay, this is facing up, so we know it's going to be something like this. Let's find the vertex. So let's go x equals -b over 2, and a is 2 as well. That's -18 over 4. This one might not come out so nice, so I'm going to go with my calculator. -18 over 4, that's -4.5, 4.5. Okay, so there's where my axis of symmetry is. Let's try to graph that. So -4.5 is about right here, right? Something like that. So we'll say what it is. Make sure you label it. Sounding like a broken record. Okay, there we go. We're going to plug that back in. Definitely going to need our calculator this time. So y equals 2 -4.5 squared plus 18 and -4.5 right up there, 2 minus 72. And you know what? I'm going to type that all into my calculator. I wish I could show you, but I don't have a window for that. So let me type it all in my calculator. And wow, I got a really small number, -112.5. So the vertex on this guy is way down there, -4.5 and -112.5. So this would be hard to graph unless you change the scale, right? You could say that this is like, I don't know, maybe this is -50 and this is -100. So the vertex is kind of down here. You're allowed to do that on my problems, okay? Anyway, so then it's going to go up right here. Oh, it's actually supposed to go through -12, but you can imagine. Okay? Oh, I have to sneeze. Okay. So domain, like we said, all parabolas go left and right infinitely, so they cover all the real numbers. If you plug any real number in, you're going to get a value somewhere. If you plug this one in, you get this value. If you plug this one in, you get that value. If you plug this one in, you get that value. If you plug in 1,000,000 way, way down here, you're going to get a value way, way up there somewhere on this guy. Okay? The range looks like this guy has a minimum again, and its minimum is that it's pretty small, negative 112. And then it keeps going up and up and up to infinity, and remember this should be a bracket. Okay, let's see what else we've got. Another one of these. This one looks like it's going down though, because it's got a negative a, so a little different. Okay, let's factor it. So I think, once again they share a 2. I've made these problems as easy as I could for you. You know what, let's pull out a negative 2. You could pull out a negative or a positive 2. If you pull out the negative, if there's a negative in front, it's always going to make your life much easier, so make sure you do that. So I'm going to pull out a negative 2, x squared is left. If I pull negative 2, divide 4 by negative 2, and I get negative 2. Oh, the x is left 2. And then 6 divided by negative 2 is negative 3. Yeah? Okay. So then we say, okay, can we factor that? I think that's the same thing problem 1 was at the very beginning, isn't it? I guess we could go back and look. Problem 1. Isn't that the same exact problem? Not that it really matters, but yeah. Oops, sorry, too much flipping. Yeah, I think so. So we're going to go 3 and 1, and a negative 3 and a positive 1. That adds up to negative 2. Okay, so this one's going to give us x equals negative 1 if we set it to 0. This one, if we set it to 0, you know what? I'm just going to do it this time, just to make sure I don't make a mistake. Then I'm going to add 3 to both sides. And if I'm going too slow for you on that, I'm sorry, but it's nice to kind of see that a few times at least. So we have these two zeros, 1, 2, 3, right there, and negative 1 right there. Okay, vertex, negative b, so negative b is 4 over 2, a is negative 2, so that's going to be negative 4 over negative 4. Oh, that's positive 1. That's nice. So we have a line of symmetry at 1. Does that make sense with our picture? You always want to make sure if this makes sense. Right here, does it look like that's right in the middle? I think so. That's right in the middle between negative 1 and 3. Okay, then we plug it in, so we get y equals negative 2, 1 squared, 4 times 1 plus 6. So it's going to be, what, negative 2 plus 4 plus 6. 4 and 6 is 10, minus 2 is, you guessed it, 8. So our vertex is at 1, 8. I have to do a little colon there. Okay, so 1, 8. So if this is like 10 up here, then it would be about right there. And of course it's going to have to go down to go through these zeros. That makes sense logically, but also recall this guy is negative. If a is negative, it has to go down. Alright, so it all makes sense. So there's our parabola. Its domain, same old boring thing. Negative infinity to infinity. Its range. This time I think it's going from negative infinity up, all the way up, up, up until 8. A nice bracket on 8. And that means that 8 must be the maximum value it ever gets to. Okay? Alright, let's look at one last problem. Okay, here's a bit of an application. So it says the height in feet of a soccer ball, and they drew us a nice graph already. Nice, it's got height. Can be modeled by this quadratic function. It says where x is the time in seconds. It'd usually be better to use t in there, wouldn't it? But okay, they used x. So we've got time and height. It says find the soccer ball's maximum. So isn't that like the vertex? I think that when you see something about a maximum or minimum, at least in high school, Usually they're talking about some kind of vertex of a parabola. Okay, maybe not, but we'll see what other things they could do another time. So then it says find how long the soccer ball is in the air. You know, I don't even know what that means yet, so I'm just going to draw this. So I'm going to try to draw f of x, just like we've been doing before. So let's factor it first. So let's take this guy down here and say, what can we do? Two terms, do they share anything? Or is it difference of squares? This isn't squared, right? 24 and x, no way. Oh, but they do share stuff, right? We could pull out a negative 8. We pull it out there, we have x squared. We pull out negative 24 divided by negative 8 is negative 3, right? Oh, and I forgot the x. Let's fix that, right? So negative 3x is left there. Now, okay, Oh, you know, they both shared an x. You know, I could have just done that a better way. So sometimes you miss that and you just want to start over. So I say, hey, they both share negative 8, but they also both share x. So I can pull that out, and we have 1x left there. And we're still going to have our negative 3, but we pulled the x out now. Okay, cool. So then this part, negative x equals 0, and then x minus 3 equals 0. You guys probably think my handwriting is terrible here, but it's just the way it goes. Sorry, so I'm going to have to add 3 to both sides on this one. And this one I'm going to have to divide by negative 8 on both sides, right? Okay, so those cancel and we get x, what's 0 over something? Doesn't even matter what the something is, it's 0. And over here we're going to have 3. Okay, so let's think about this. We've got our zeros, let's plot them. So if this is 1, 2, 3, then one of them is right there. One of them is right here. This parabola is facing down because of that guy, right? So let's find the vertex, just like we did in our other problems. So x equals negative b. b is 24 over 2a is negative 8. So we have negative 24 over negative 16, is it? So that's going to be positive, what, 1.5? Let's get our calculator. 24 over 16, yes, 1.5. Okay, that makes sense, I think, because that's about right in the middle of 0 and 3, right? 1.5. So let's put that axis of symmetry on there at 1.5. Okay, we'll go plug it back in. So y, oh, you know what? They have it labeled as a function. I'm going to do this correctly. So important to understand functions. So it says f of x. So f of 1.5, that was x, wasn't it? Then we're going to plug it in. So that just is the way that this is written. And plus 24 times 1.5. And I'm going to need my calculator. Let's see. So when I do this part in my calculator, what do I get? I got negative 18. And then 24 times 1.5. I got 36. So that's going to be positive, right? That's like 36 minus 18. I think that's 18. So if this was like, I don't know, 20 right here, then the vertex would be about right here. And we'd have a parabola going up, 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 like that. Okay, so let's see if we can answer their questions now that we've drawn that. So it says, what's the maximum height? Oh, that's just right up here, right? That's how high that soccer ball gets. So that's going to be 18. What are the units on this one? Feet, I see it right there on the axis. So make sure you get your units on there. Done. Time to reach the maximum, how long is it going to take? Oh, the time is this x-axis, so isn't it going to take this long to reach it? So that's like the x value of the vertex, and I think that's 1.5. Oh, man, that got pretty sloppy. Let's get this in here. So 1.5, and what are the time? Seconds. That makes sense. I mean, if you kick a soccer ball, it's not going to stay in the air very long. And the final question is time in the air. So I think as soon as he kicks it like right here. I think this is the spot he kicked it at. And then the soccer ball flew throughout this parabolic path And then over here it finally goes back to 0 height. So this is where it hits the ground. This is the impact spot of the soccer ball. So how long was it in the air? I think it was in the air this time right here. Oh, and we know what that was. That was our 0, right? So that was 3 seconds. See, so problems like this can be pretty neat, important stuff. We might actually be able to do this with some rockets at the end of the year if you guys do well. So we shall see. Have a good one. And I hope you use these when you're doing your second worksheet and getting ready for the test.